On August 26, 2026, a massive flash flood tore through the Bhote Koshi River Valley on the border of Nepal and Tibet. The disaster left at least 95 people dead and hundreds more missing. Yet meteorological sensors recorded clear skies, confirming precipitation did not cause the surge. Instead, a sudden geophysical anomaly triggered the event, striking local communities without a single drop of warning rain. Traditional early morning systems rely on weather tracking. Because this flood generated from the ground rather than the sky, those systems remained completely silent. This split data visualization compares regional weather and seismic activity, showing negligible rainfall of less than 7 millimeters, alongside a sharp seismic spike precisely at 8:37 a.m. That spike represents a 4.4 magnitude earthquake recorded by the USGS on the Tibetan side of the border. Climate researchers assess that this specific tremor dislodged an enormous ice and rock avalanche, which collapsed directly into the Lhende River, a key tributary. The massive volume of debris formed an unstable, temporary dam across the waterway, forcing rapid and immense volumes of water to pool upstream. The combination of a sudden seismic jolt and steep glacial terrain secretly accumulated thousands of tons of kinetic water pressure right above densely populated areas. At approximately 9 a.m., the immense water pressure overpowered the blockage, causing the temporary ice dam to catastrophically fail. A concentrated wall of water, mud, and debris surged across the border, instantly obliterating the Timure and Syaphrubesi market areas in Nepal's Rasua district. The kinetic force of the surge completely eroded the foundations of heavy infrastructure, pulling multi-story concrete buildings and fortified police outposts directly into the current. The floodwaters also inflicted severe damage on the regional energy grid, overwhelming major hydroelectric facilities like the Chilime power project. Barely 23 minutes passed between the Tibetan earthquake and the destruction of these border towns, leaving civilians with no functional window to evacuate. The torrent maintained its momentum as it tore southward, multiplying the disaster zone as it swallowed terraced agricultural valleys and adjacent highways through Nuakot, Doding, Chitwan, and Gorkha. This chart breaks down the staggering human cost among the 384 individuals reported missing, specifically highlighting the presence of 105 Indian nationals, 12 UK citizens, and 74 Nepalese security personnel. This highway serves as a primary transit artery for tourists and Hindu pilgrims traveling to the sacred snow-dusted peak of Mount Kailash in Tibet. Because the flood struck a major international travel corridor, a localized infrastructure failure immediately escalated into a complex, multinational recovery operation. Active, high-risk rescue operations are currently underway, with the Nepal military deploying 14 helicopters to extract stranded survivors directly from isolated rooftops. Authorities warn the threat is far from over. Upstream blockages remain lodged in the river, posing a severe secondary flood risk for downstream communities as far south as the Indian states of Bihar and Uttar Pradesh. The Nepalese government has activated full state resources for disaster management and issued urgent appeals for international coordination to manage the overlapping crises. Until Himalayan nations integrate advanced seismic and geophysical monitoring into their river sensors, mountain communities will remain dangerously exposed to these rapid, cascading disasters.